So, hi, welcome everybody. So, let's go. And now, you're waiting for this presentation to start. And, well, it took quite a while, don't you think? It was like about 10-15 seconds. And how you guys reacted to this time basically depends on what you expect from this. Because you all came in here with different expectations, with different conditions, different contexts, etc. And so, within these 15 seconds, 10 seconds, some of you guys might get bored, some of you might get annoyed, frustrated, or even you're still excited. You can't wait for the presentation to start. So, to summarize, how you feel during the waiting time is basically dependent on what you expect. Because some of you went through the agenda of the Fluttercon and found this talk, read the summary, read the title, found it interesting and came. And others, after a healthy lunch and a good lunch compared to last year, you maybe just wanted a nice warm chair to sit and just relax for a moment, and you don't really care what's happening. So, but if you're interested, you're excited, you can't wait for this to start. Otherwise, if you just want a chair, you might get bored. You're not interested anyway. But I see it's full actually. Some actually are on the floor, so thanks for the effort. And I had some big competition, like real-time communications, quite something, so thanks everybody for coming. So let's ask with a kind of silly question. Let's start with a kind of silly question like, what is waiting in the end? And waiting is experiencing time. And I could now go for the philosophical approach and tell you about time, the great mystery of time, the great constant in our lives and everything. But I think there have been enough movies and books and art and science that have already covered that in total. And for me, as just a software developer, it would be kind of cheesy to talk about the big concept of time. But to summarize, and I think we can all agree in the end, is that time is pretty important to all of us and to everything. So, in Bremen, my hometown, is a cinema. And it's called the Schauburg, and it's kind of an art house cinema. And so it gets kind of, it does experiments sometimes. And one of the experiments is the sneak preview. So every Monday there is one movie, but it's a mystery movie. You don't know what you get in the end. So it could be anything. It could be Transformers, could be a Marvel movie, could be a French family drama, or one Indonesian thriller. You don't know what you get. And so usually a movie takes about, like, let's say, about 2 hours. And so if you're entertained by the movie, or you feel touched, or this story just captivates you, this 2 hours might feel much, much shorter to you, because you're in it. Otherwise, if you're bored and the movie is nothing at all for you, you're not interested in the topic or the story at all, 2 hours are a long time. And that's basically what I'm talking about. And to summarize with a quote, if you're sitting with a nice person for hours, it feels like minutes to you. But otherwise, if you're sitting on a hot stove and you're burning yourself for hours, for minutes, it feels like hours. And you might have guessed it's Albert Einstein who said that quote. And so, to perceive time, or how you perceive time, is in the end dependent of the context that time is passing in. And this applies to literally everything. And that everything obviously also includes software. So, welcome to, just a moment. Welcome to the perception of time in user interfaces. So I'm André Schmidt Di Salvo. I'm a senior Flutter and Android developer at OpenExchange, currently working on a cloud storage client. And I've been doing software development for around 20 years now. And I don't want to brag, but I basically did everything. So I developed for like tiny startups who just had like some sentences of concepts up to multinational corporations who basically had every detail specified in pages over pages of specifications. But all of these softwares that we had to develop, all of these apps that we had to develop had one thing in common. And this is, in the end, that all these softwares need to load. They need to get resources, they need to get data, and this requires time. And that, in the end, makes the user using the app, makes it that he has to wait. And so waiting requires actually one resource, one fuel basically, one gasoline, and that is patience. And when your patience runs out, then a reaction will follow. Going back to the cinema example that I had before, if my patience runs out, I would just leave the movie. For example, there's one friend of mine who really likes the French family drama, and as there was a Marvel movie in the cinema, he just left. So, when it comes to software, it depends what I expect from the software. For example, if I'm bored and I just download one game and I don't really care about it, and the game starts basically with a long progress, having to install all kinds of stuff, getting extra packages from the internet and so on. As I don't really care about the game, I will just uninstall it. Who cares? But if I have a game and I waited for it for like 1 year and I actually pre-ordered it and I'm really excited and the first loading screen appears and it takes forever, I'm still excited because I really want to play that game, but that might also very soon tip over into frustration. And if I'm at work and I have a cloud storage and, for example, I have to get this presentation to show to you guys and it just doesn't react, just the syncing to get the file takes forever, well, that will leave me pretty frustrated or even panicky because all you guys are dependent on me or are eager for me to tell you guys some stuff. So, and when the patience runs out, following all these different kinds of emotions, or these bad emotions, at least a bad review for your app is imminent. Or you go to a forum and you complain about it, and other people chime in and say like, really, how can it be so slow? So we need to handle the patience of our users. We need to work with it. But first we'd like to ask the question like, how long is really too long? And about that, about how much time a process in a software can take until it gives feedback to the user, there have been many papers and standards and theses. And actually, for example, in 1968, there was one paper called Response Time in Man-Computer Conversational Transactions. And you see, it was already 1968, so people have been dealing and wondering about the stuff for quite some while. And there have been also standards, for example, in the military sector for how long it takes for a certain action to perform. And if you have like games, etc., if you have software or different kind of apps, these are mostly like for your pastime, maybe also work-related, but something like the military sector, obviously, it's critical that some stuff finishes on time. So for our talk, I don't have any paper prepared that I will recite, don't worry about that, but I prepared 3 categories, actually 4, but 3 important ones. And the first one that we start with is called now. And now is really like this. It happens instantly. So there's no really any waiting involved. It's just now. And one good example is take your favorite messenger, WhatsApp, Telegram, Signal, whatever you use, and you compose a message, and you press the send button, and your message immediately appears in your chat history. Done. But the question is in the end, like, how much time do we actually have that it still feels instant to the user? For the chat bubble to be right there immediately. And the answer to that is 50 milliseconds. 50 milliseconds is when the stimulus basically reaches your eye, goes to your brain, and you become conscious about a change in, for example, your user interface. 50 milliseconds. So 50 milliseconds is it's not that much time, as you might agree. But anything that breaches those 50 milliseconds feels like a delay. Maybe not a big one, but, well, especially from gaming, we know the term lag. It feels kind of sluggish, it kind of drags out a bit. So it's basically a micro-waiting. So, and yeah, as I said, even though it's just a chat bubble to display, 50 milliseconds is still not a lot of time. And it starts with our code. Especially in Flutter with the tree of widgets, if we are not very careful about how we build that tree of widgets, it can get sluggish. But hey, we are coders, most of us at least. So we sit down and we optimize and benchmark the code, and hooray, we are under 50 milliseconds. Well, on our device. Because what you have to understand is that actually the context that our app is running in, or the environment that our app is running in, is basically ruled by chaos. Just think about it, like on your phone, how old is your phone? What's the hardware of your phone? How fast is it? How slow is it? You know, what kind of state is our system on the device in? Is the battery saver on? Or are there also other apps that are downloading stuff or performing heavy computations that are basically dragging resources from the system? So these are all basically factors that we have no influence in, and in a very limited fashion can find out about those factors. So that means in the end, with all those factors on top of our code, which we can still control, there needs to be like a lot of space that we can accustom for all these different devices that we have to support, especially with Flutter. So we have to get it much, much below 50 milliseconds. And so what I can recommend you is take the oldest, slowest device that you have. And if you get it under 50 milliseconds, obviously it will run on any other device just fine. So right now you might think like this is very petty, or as we say in German, like kleinlich, to think about this kind of milliseconds, you know. But if these adds up, if basically everything that you do in the app is kind of off, just takes a little moment later, it will feel kind of sluggish, it will feel laggy, as we say. Or if you, for example, you completely optimized your whole app, and then you introduce one new feature. And that feature had to be kind of rushed to market and is still not optimized. You feel the difference between your complete nice and fast app and that new exciting feature, which still lags a bit. So, but talking about the chat bubble, there's still one trick applied to that. And that is basically that we fake it until we make it. Because if you think about it, what is all involved to send one message? Of course, it's not only displaying the chat bubble, that's the faking part of it, you have to persist the message to send it later. And of course, when you can send it later, when you finally have connection, you need the network, and you need to send it over the network. And of course, all these factors take much, much longer than 50 milliseconds. So what is being done actually is that we already present to the user, yeah, it's done. You can leave now. You've done your job. And everything else is kind of done in parallel or done later. So we fake it until we make it. For the user, we are all tech people. We know what is involved in that. But for example, for my grandmother, she just sees, okay, it's sent, I'm done. So we fake it till we make it. But what if it takes longer than just those mere 50 milliseconds? And then we get into a category called, that's the hardware I was talking about. We get to a category called in a moment. And a very fine example about in a moment is a login. You enter your username, your password, you click on login, and it takes a moment until you're logged in. And here we really can't fake it until we make it because we have nothing. We just started the app, and we just logged in. All the resources, all the data have to be dragged from servers to our device. And so we have to show something. And as you see in the beginning, we need the so-called indeterminate progress indicator. The little spinny thing. You all know it. You have seen it. So, but especially with the login, what is now introduced into our, let's say, chaos is basically the king of chaos, and that is the internet. So the internet, in the end, is basically, can either on our phone or our desktop, etc., can react like in a very short time, or it can take a very long time. And, well, first of all, to clarify something, the internet, if you have your browser open and you go to your favorite website or Amazon or YouTube, etc., what you see in the end, that's not the internet. That's just data on a computer that is being presented to you. What is the internet is the waiting time that you experience until the website is done. And just think of all the stuff, all the factors that are basically creating this waiting time. For example, are you on a Wi-Fi, or are you or just on a mobile signal? Are you on one of those awfully slow free Wi-Fis? Or are you at home with your fast Wi-Fi? Or are you on a mobile signal and you're in the city center and you have great reception? Or you're on a train going right into a tunnel right now? Or is your server, is it basically that you're trying to contact? Is it right next door? Is it in Greenland or Mogadishu or who knows where? The thing is, you don't know that stuff, so you can't control that. You don't know. So because the time ranges basically from mere milliseconds up to infinity. And so there's always been one crude solution to infinity, and that was always timeouts. And usually in modern HTTP clients, the timeouts are like by default set to 10 milliseconds. This is about like this is basically like what has been defined as the maximum patience for a user in the terms of login and internet related stuff. But beware, because it's not only about the connection, how good your connection is. It's also about how the server is actually performing, how much data the server has to assemble, has to calculate, etc. So this is also something that has to be taken into consideration. So, but 10 seconds in the end is actually pretty long. You've seen in the beginning when you were waiting for this to start, 10 seconds, well, it's quite a while. But what if it takes actually longer than 10 seconds? And this is where we enter the later category. And as an example for that, we take again the login. So if the login basically takes longer than 10 seconds, you really maxed out the patience of the user. And so what you can do in this case is you can at least excuse yourself. You can at least say something like, This takes longer than usual, please wait. And I know, and for the user himself, this is obvious this takes longer than usual and that he has to wait, but it's basically like a thank you. It's implicit, but it's still nice to hear it or to read it. But on top of that, there's actually much more stuff that we can do. We can also evaluate certain things. If we not only think about the login, but we're waiting for other data to get to our client, we can, for example, we know how much it will be more or less. Will it be megabytes, gigabytes, whatever, or just like some hundred bytes? So with this knowledge, we can already show different kinds of different waiting states. And we also, for example, know the connection type. If you're on a Wi-Fi, okay, should be fine enough. And there's another issue. If you're on a mobile signal, okay, makes kind of sense. So we can at least say this is taking longer than usual. Maybe you want to switch your Wi-Fi. Maybe you want to switch your network. For example, the IMDb app does that. And of course, there's usually, like for this long waiting times that you have in software, games are a pretty good example. Because in games, they're like huge masses of textures and sounds and logics that have to be loaded into memory. So it really, really takes a while sometimes. Of course, also depending on your hardware, etc. But usually it takes a moment. And games get really creative over the years. For example, you have this kind of loading games. This could be like a loading game from a role-playing game. And it gives you like some tips and tricks that you maybe didn't know. You know, you can do this at a vendor, you can visit that area of the map, etc. And you are entertained. Like while you're waiting, you get some useful information. You're like, oh, I didn't know that. Thanks for that. You know? Or for example, I'd like to play Forza 5, which is a racing game. And while loading the game, it shows you all kinds of nice statistics. Like how many times you have won the first place, how many cars you have in your garage, and or how much time you have been racing in total. So, and these are all things that you can track, kind of like analytics. So it's kind of free data that you can use to basically, once you have places in your app that require quite some waiting time, you can put there to entertain the user. That's nice to know. And some games are really going overboard. Like in 1993, there was a game called Strike Commander. And Strike Commander was from Origin Systems, and the founder does like Star Citizen, I think it's called today. And Strike Commander was kind of revolutionary for a time because it had like really, really good graphics. But also the developers knew that there are many, many systems that are not up to the load, to the resources that are needed for that game. So the loading, I had a fast computer during that time, but the loading took like literally minutes, like 3, 4, 5 minutes. And so what Strike Commander did, it let you play Pong. Yeah. And for me, at least for me, that was nice because at some point I was actually waiting to play Pong because I could, until I could actually play the real game, and I didn't care about the minutes it took. No problem. No? So to summarize, if it takes much longer than the user can bear in his patience, explain to him what's happening. Give him one excuse, just one lame excuse. Maybe explain it really like, oh, your connection is very slow today. Do something about that, or entertain him. With Pong, for example. The fun part is actually, there had been a patent on this kind of mini games while waiting. And this patent actually ran out in 2015. So, go ahead. There's one other category, which I will just cover very shortly, and I'd like to call that in time. And this is actually when we have two factors together. We know how much data we need, and we know how long the chunks of data needing. And a good example of that is obviously a download. I know the speed to download something, and I know how much I have to download. But nowadays, nobody wants to see that anymore, really. And there are very few applications today that really do this stuff. Of course, if you have like one app from one TV station and you want to download one episode of one series, it makes sense. But this detailed information, like 0% to 100%, and it still takes like 2 hours and 50 minutes and 20 seconds. This is just too detailed for most users. So much for that. Yeah, exactly. We also have games. Games know about the loads that they have to do, about the stuff that they have to load, about the textures, etc. But even in games nowadays, you don't have that progress. And usually you know that phenomenon that you have 100% and it goes to 50 and to 60 and to 70 and to 90, 95 and 200. And this is annoying. This is very annoying. So most don't do that anymore. That just shows us really like this percentage, this linear progress bar, etc. But games are getting like quite creative nowadays to hide, to fake it until they make it with loading data. For example, there are games like God of War or Shadow of the Tomb Raider, and maybe you played these games. You're like out in the open and you're doing what you do in that games, and suddenly there's like one very narrow space that you have to kind of squeeze yourself through to get to the other side of a mountain or of one hallway or whatever. And this is like a cheap trick. It's not a cheap trick, it's a nice trick actually, because during that time, the player and also the viewport of the player is kind of locked into that space. So you can unload all the data that was behind you and load all the data that is coming up, because what you're basically displaying right now is so few that you have enough processing power to load all the other stuff. And this is just one example how you can basically fake it till you make it in games, and yeah, it's a creative solution in the end. So, but to summarize, yes, this is one linear progress bar I was talking about. But to summarize the more interesting categories in this presentation, now can take up to 50 milliseconds. In a moment is beyond that and should take up to like 10 seconds, and later is 10 seconds to basically infinity. So, I guess what you Flutter people are also waiting for is, let's create one widget for that. So as a content, let's start with our famous Flutter logo. And we are in a kind of dilemma actually in the end, because if we can't fake it until we make it, so we can completely hide the waiting time, the time that is needed to do stuff. And if, for example, the internet is a factor in this, our waiting might be a very short time, or might be a very long time. You don't know. So, but we don't want to show nothing for a very long time. And if we have a very short time, we don't want to bombard the user with like explanations and excuses, etc. and so on. Because, well, then the UI, the user interface, gets kind of uneasy in a certain way. So what we have to do in that case is we slowly have to escalate. We go from like very little representation of the waiting to more and more and more over the time of all defined categories. And so the first thing that we can do is we can just squim it. And squimming is basically just fading out. And it's one very, very subtle and nice way to show something is happening here. But it's not as invasive as a whole screen showing you tips and tricks and excuses, or also even your spinning indicator. So for very short time frames, this is just nice. And next we have, I guess, one of the most used widgets ever, because everybody saw this one. And your parents saw it, and your children saw it. And for example, you guys know this pin of Google Maps. And this pin on Google Maps actually made it into one museum for iconography. And this should go as well, in my opinion. So I plead for that this goes into a museum, because this is basically the new save symbol, the new disk symbol for saving. You know, everybody knows, now we have to wait a moment. But if this took a long time already, let's say, to 10 seconds. So we're losing our patience. Then we have to explain ourselves. And I was lazy, so I built this. I didn't want to build like a whole role-playing game loading screen. So I'm not a designer, etc. So this is just please wait. So the user sees something is happening, and please wait is just one excuse, one explanation. So, and to put everything together, we have a short moment of scrimming, showing this progress indicator, and then in the end we have something more to explain. This will take a while. This now took longer, obviously, than 10 seconds, but we don't have so much time. Actually, we do, but well, as you can see, basically we went through 3 different stages, and every stage basically transisted through animations from one step to another stage. And I'd like to show you the code, how I did this, but it's a lot of code. So if only there would be one package with one GitHub repository which you can immediately use this widget and also have a look at the source code, and lucky you, there's one available. So what you have here, what you can see in this or find in this package is, a waiting widget. And it does everything. Basically, you just have one flag that you have to switch, and it goes into this animated state. And if it takes longer, it also goes over to this later state and so on. And once you flip the flag back again, it just fades out again. And it's customizable. You can replace your progress indicator with something other nice. For example, how many of you guys know Lottie? Yes. And it's nice. It's really nice. It really brings together designers and developers in quite a nice way. And of course, you can also define your later stage. You can set a timeout, and you can set a timeout indicator. And an indicator is, of course, in the end, in our case, just a widget. So it can be a whole screen if you'd like to. Right. As you might have guessed, this is not like one PowerPoint presentation. Actually, below this waiting widget that I wrote is one scene API to create transitions between widgets. And it was used to write this presentation. So, if you're interested, for your consideration. So we are nearing the end. And until now, we basically tried to work against time. Everything that took longer was basically bad for us, so we kind of had to escalate and explain to the user and excuse ourselves, etc., and think of ways to basically entertain them and so on. But yeah, we basically want to wait as short as possible. But the thing is, in the end, why don't we also give our app a little bit of time? And this is in the end where I come to something called acquired patience. Because you have to understand, if you download one app or one piece of software on your mobile phone, on your desktop or whatever, the user is new to the app. He doesn't know how it's behaving. He doesn't know if it's slow or fast or anything. He's completely new, and you have to give him the first impression of your app. And for example, if you basically give your app a little time in some circumstances, the user will basically get accustomed to these delays and get used to it. I think you guys know all this stuff. If you open one app and, for example, you just have the splash screen, you know you have to wait 2 seconds until the real app opens. And you're not pissed by that because you're used to it. And so what I'd like to propose is that if you have processes that take like a very short time or a very long time because the internet is involved, etc., we had all these factors and so on. Why not kind of try to find one medium? And let's say, okay, this takes a minimum of 500 milliseconds. So the user knows in the end. For example, if the user is also used to that it takes like about 1 second, and one day your internet is fabulous and it just takes like, let's say 100 milliseconds, it's like, whoa, what's up today? And of course, it's faster, but it feels weird because the rhythm is off, right? So, when I talked to colleagues of mine, other people, this was kind of created one controversy in a certain way. Some people were like, no, I want to have it as fast as possible. Others were like, oh, that could make sense. But maybe I could kind of at least get you thinking about it, maybe inspire you a little bit. And well, that's it. So, thanks a lot for coming.